Okay, so what I'm so the first chapter I said is the introduction to information systems. Let's see the what we will discuss in this chapter. So the first one would be data, information, and knowledge. So you might have came across these concepts before. So we will talk about them to just refreshen your memory. And system and information system would be the next issue of discussion. Then we will talk about the views of different systems. And then information technology, information communication technology. What are they? What's the difference between them? And then we will talk about technical aspects in hardware and software that are specific to computers. So we'll talk about what computer is, how it works, and then finally we will talk the health information and health information systems in this very chapter. So the first one is data. So as you might already know, data is raw facts and figures and different details. So this means that uh, data by itself has no meaning. So an example for data would be, for example, say 35. You say 35 is a number, but by itself, if you don't add context or meaning to it, 35 might be the age of a person, 35 might be a kilogram, or other different meanings can be assigned to it. So the first thing is you need to have a context. So if it is a raw data, uh, it is a data. So uh, data means any collection of raw facts and figures. So data can be considered as the raw material of information. So it is after data that information can be found. So that's the basic concept. And as I said, information is more of an organized, meaningful, and useful interpretation of data. So well, after having the data, you will add context to it, or you will add meaning to it. That will in turn be an information. So this is like after analysis or after a process, data turns into information. So in summary, you can say it's a collection of meaningful facts and figures that can be used as a base for guidance and decision making. So in information, you can answer the questions like what is that specific number telling us about, who is that about, when was that, and where. These questions give the data a context and turns the data into information. Uh, so that's data plus meaning gives you an information. So the other one is knowledge. So knowledge is it is an awareness and understanding of a set of information and how that information can be put to the best use. So it's likely includes facts about the real world entities and the relationship between them. So after amassing or collecting information, those information uh, would tell you a specific knowledge. They would likely indicate uh, a specific area of knowledge. So usually we use the how question to detect if it is knowledge or not. So uh, you have data that is a raw fact, and then you have information that's add meaning to the data, and then finally the collection of information and gathering of experience and impact will give you the knowledge aspect of the hierarchy. So it is information plus application or the use of that information that gives you knowledge. So there is this famous pyramid called the IKW hierarchy. So this is the data, information, knowledge, wisdom hierarchy. So as you can see in the bottom of the pyramid, the raw data in a pyramid, the bottom is like there is a vast amount. So if it is large, that means there is a vast amount available. So data is very huge in nature. And then after further analyzing that data, you will get information. So information becomes much more uh, lower in existence or abundance, and then knowledge and wisdom that will be more and more specific and less in number. So that is something we need to note of. So as we climb up the pyramid, the extent or the abundance decreases. So this is something to keep note of. This was like a question for you. What is a system? So a system is the collection or the set of interrelated components or parts that work together to achieve a specific objective or a goal. So we can mention systems exist in wide variety of contexts in the universe. So take the human being as a system, and the human being is composed of systems like, for example, respiratory system, GI system. So if you take the respiratory system, there are different components in it, so including the lung, the different breathing components. So this have like the overall goal of achieving the or processing the intake of oxygen and then distributing to the body. So they have a common objective or goal, and then they have like this specific connection. So there is a connection between the different parts. So having said that, we will take this concept to information systems. So information systems, in a turn, as I said, like a system, they have components that collect. That means that inputs, and then that manipulate or process, and then disseminate outputs or data and information, and provide feedback mechanism to meet an objective. So as every system, information system has also an objective. So this objective might be different from place to place, but the overarching principles of this objective uh, is achieved by the different components. So an information system will have an input, and there is a process that transforms this input, and after that there is an output or dissemination of this specific information or knowledge that is generated. So after all, they will achieve the same objective. So uh, it can also be defined as the combination of information technology and people's activities using the technology to support operations and management and decision making. There are different views of system, so we can see systems in from a different perspective. So one of the perspective is structural view, and then functional view, service view, and object orientation view. So this apply to different kinds of systems. So for example, take the structural view. This structural view focus on system parts and nature, their nature. So this is the information system as composed of data that is inputted, and hardware and software that are used during the process of the process of analyzing this data, and then user procedures also play their part, and this is the concept that's most cited. So structural view sees the information system from a point where the different parties that are participating in the overall system. So it identifies the structures of the system. The other one is the functional view. So as you can see from the name, function means that the certain activity is performed. So whereas structural view is the structures that perform the functions, functional view focus on the activities that are performed. So it is the application of general concept of system to information system. So this says the information system is composed of inputs, input part that takes the data in, and processing part that organizes and transforms data, and finally the output part. So it classifies them based on the functions or the activities performed within an information system. The other one is service view. So this is similar or closer in concept with the functional view, with a clear focus on data services. So this perfect example is client server model. So where there is a central server that has all the information needed, and that can process whatever is necessary or whatever is required by the client. So there are different clients, as you can see from the picture. There is the internet or networks, and then there is a central server. So different clients using from different devices access this server. So this server serves them. That means gives them a service through the networks, and the clients get service. So this specifically focus about the services or the server uses in practice. So we can have different types of services. The first one is data storage service. We can use, for example, take the Gmail. You have a drive that you can access, right? So you can store up to, if I'm not mistaken, 12 or 14 gigabytes of data in the Google Drive. So you can use the data storage service that is. So the other one is data processing service or functionality. We will come to this concept later on in the third chapter. So data processing service or functionality is offered by different vendors. So this is one of the service we get as health information system interested, or we are as our interest is focused on health information system, we have different vendors that can offer us a processing service, and the other one is user interface service. So this is when we use different APIs or application programming interfaces to interact with different systems. So we can also get different user interface services. So the service view views the or has a different perspective than the functional view in terms of the concept is mentioned. The other one is the object orientation view. So there's in information system there's this uh, perspective called object oriented programming or analysis and design. So this concept basically means that the different participants or components of the system are viewed as different objects and they are interacting with each other. So, for example, take a hospital system that has patients and that has different charters and cards and also different electronic systems that are communicating, interacting with each other. So these are called or designated the name of an object, and the object orientation view sees the system as just the interaction between the objects and one object and the other object. So that's the objective. So service and functional view are implied here. So it might contain both views. So that means it can see services as an object and as well functions as an object. So for example, say user interface objects might be included, application domain objects or functionality and data access objects or databases or storage can be viewed as an object. So the object orientation view implies or includes the concept that's included in the service and functional view. Uh, okay, so the next one will be the differentiation of information technology and information communication technology. So information technologies are systems of hardware or software that capture, process, exchange, store, and present information using different technologies, electrical, magnetic, and electromagnetic energy. So it specifically refers to the specific technology used. So that says that there is a software, there is a hardware involved in this when we talk about information technology. So when it comes to information communication technologies, it's is the use of electronic computers and the telecommunication network. So the key word here is the telecommunication network or networks to create, store, process, and send and receive information from or to any type of device or area. So this is like a combination of computer technology and communication technology working together. So you have a network or a telecommunication system, and then you have different devices that are working together. So as said in information system, there is a specific objective associated with this different information communication technology or information systems. So let's talk a little bit about computers. So computers, well, as you might already know, you might already use them. There is their uses, and we'll specifically focus about how computers work. So the computer well originated from early counting aids and then turned into manual calculators and then programmable calculators, and finally we have programmable computers. So there are like these five characteristics that identify computers. So the first one is speed. So speed of computers is very fast, as we all know. So computers execute uh, commands or instructions within microseconds. So that is one of the very good characteristics of a computer. The other one is accuracy. So there is this term that we call garbage in and garbage out. So this indicates that whatever you input in the computer, it returns you a similar output. That is to say, if you enter a wrong input, you will get a wrong output, and if you enter a right out input, you would get the reverse one. So uh, that means the computer is accurate. Okay, so computers process information more than human in an accurate manner. So the other one is diligence. So that means computers are never tired. So they only work as good as they are working days ago. So you have that specific characteristics. The other one is storage, so they can store, so humans memory, or you can measure it or you can't measure it, is debatable, but computers store very large volumes and retrieve instantaneously. So nowadays the progression of technology has seen not only the storage but the different artificial intelligence systems or computers that are performing different levels of data storage and utilizing that data storage instantaneously to make decisions. So the last one is versatility. So that means you can use computers in different areas. So you can use them in the education sector, in the health sector, or economical sector, what have you. So you can use them anywhere. So they are versatile. Uh, so having said that, how do you think is computer speed and storage measured? So we've talked about the accuracy and the speed of computers, and then we have the different storage capabilities of computers. So how is the computer speed measured? So think about that. But computer speed can vary. A speed of a computer can vary based and depending on, the first thing is their central processing unit. So the CPU is the main or the heart of the computer. So the CPU processes information. So the speed of the CPU is mainly the speed of a computer. So usually CPUs have a speed that is labeled as in terms of gigahertz. So you have to know, like, if your PC or laptop is how much gigahertz of speed. So that's one of the measurements of speed. The other one is the other measurement is computer RAMs. So RAMs are storage of currently processing tasks. So tasks that are being used by the CPU are stored for immediate retrieval in the RAM. So the size of the RAM is also a determinant factor in the speed of a computer. So for a high level view, let's mention only the two. There are other factors, but the speed of a computer depends on the CPU speed and the RAM size. The other one is storage. So storage is dependent on secondary storage devices like the hard disk or hard disk drivers or solid state drives or SSDs that are present within the computer. So this storage is measured again, as we mentioned earlier, gigabyte, megabyte. So megabytes is 1024 kilobytes, and 1024 megabyte equals to 1 gigabyte, and then that continues to terabytes and so on. So this is the measurement of the storage and how computer storage is used in different aspects of the computer. Right, so the other one is what are the application areas of a computer. So computers can be used in as learning aids, entertainment, commercial business, uh, information utilities, routine and dangerous tasks can be also achieved by computers, and as an expert systems aiding decision making, electronic banking service, as e-commerce systems, shopping from home, household control. There are a wide variety of uses of these computers. So, well, mainly computer can be uh, classified, or computer can consist of two parts. So the first part is computer hardware, and the other one is the software. So this refers to anything that is visible, that is touchable to the human hand. So this refers to a computer hardware. So the computer software is not directly touchable, but this is made up of set of instructions that direct the computer hardware to perform particular tasks. So a computer without the softwares, or a hardware without the software, is nothing. It can't perform nothing. So you would need to have a set of instructions that govern the computer, that instruct the computer to do different tasks. So these are the high level classifications of computers. So in terms of computer hardware, we can talk about system boards or motherboard, which houses processor, hard disk drivers, and different components of a computer system. And the processor itself, as we mentioned earlier, it is the heart of the computer, which does the different processing tasks. And the third one is memory or storage. So we have a random access memory, we have read-only memories, and a storage as well. So the other one is power supply, which regulates the power coming from our AC adapters to into the computer. And then input and output devices can be mentioned. So input and output devices are, as said, the devices that are responsible for accepting data and then outputting or displaying data to the user. The last one is peripheral devices. So this can consist of devices that are attached or plugged into our computers. So this consists of mouses, different memory cards or hard disk drivers that are attached to the computer. So system board or motherboard is the largest circuit board inside the case that is used to plug every connection. So it holds the processor, memory, and expansion slots. So this is basically this what the system board looks like. So it has different components, and these components interact. So it houses the processor, I say the different graphics cards or graphics processing units that process high level or high sized graphics data, and different connections, LAN or internet cables are connected to this motherboard or system board. So this is like the computer itself. So if the motherboard is not working, so the computers can't work. So that has to be noted. So the importance of the motherboard is it organizes different components of the computer. So it is well designed to dictate how the entire computer is going to be organized. So the other one is control. The motherboard contains the chipsets and the BIOS. So these are uh, the diff. So for example, BIOS is the basic input-output system, and there are different chipsets that have specific responsibilities. So these chipsets control the different hardwares in the computer. So in such a way, the motherboard is responsible for controlling the overall system of the computer. So finally, communication. So there are different ways of communicating, as said. So one of it is using the different peripheral devices. So these devices connect to the computer, to the motherboard, and work or function smoothly in the computer system. Uh, and then processor support, peripheral support, and performance can be mentioned at the uh, functions of the uh, motherboard. So the motherboard determines the type of processor, memory, system buses, or information or data highways and hard disk interface, and these components dictate directly your system's performance. So as mentioned earlier, the speed of a computer determined by the type of processor you use and the speed of the processor, that is and then the memory of the processor, the size of the memory. So this is found in the motherboard. So the quality of the motherboard, circuits, and chipsets themselves have an impact on performance. So as well, so there are different types of motherboard, different manufacturers. So that has to be also taken into consideration when deciding which motherboard to go with. So I think we have discussed what the the processor is. So I will stop here and check if everybody is following.